I'll kind of show you what those look like. This gives you the shape of the data frame, so it's 150 rows by 4 features. Okay. Head just says, with a 10, it just says show me the top 10 items. Remember, these are the iris data, show me super length, super width, and all of that. Okay, just give you guys a sense of how you would manipulate. We talked about all that. This is when you're sitting at your machine, how you might manipulate it a little bit. This is what I said earlier when I first get the data, what I like to do. I like to describe it. And remember, I like to look at the counts. All those are good. All those are the same number, so I know I don't have missing data there. Okay, look at my mean standard deviation. Remember we talked about the interquartile range? That's why it shows 25 to 75%. That's the interquartile range. Okay. This is the target. Remember, we're trying to predict it. It predicts them at 0, 1, or 2, depending on which one they are. There's 3 different types of iris flowers. Oh, one other thing I want to show you guys, the error that you guys got earlier. Right here, if you guys in the note, if you guys downloaded, that is a dot, and it should be an underscore. So if you're getting an error, that right there should be an underscore, not a dot. Okay.
Say it one more time.
Right there where it says iris, I think I put iris dot data, and it should be iris underscore data. And so if you're getting an error, that's probably why. Okay. Okay, and then this one I'm just doing for myself. I'm combining the two, and I'll show you why. I'm appending the class. Real quick, just so you guys know what this says is change the 0 to actually the name of the class. The only reason I did that, one, so I can see what the name is, but the main reason I did it is that when I go here, let's see if I can do this, if this doesn't take too long. This will allow me to visualize it, and it will color code it based on these names. See, so now I can see, remember we talked about linearly separate? I can see this would be fairly easy to predict. Just because I can visually see that these are linearly separable. That's why I'm doing that. By color coding it, I can separate the classes visually. Okay? And then now, remember, we take the data, the features, and put it in X. We take the target and put it in Y. So this is what X looks like. Remember what the data frame looked like up here? This is what the data frame looked like. That's for us. But the machine learning algorithm wants that. It just gets numbers. And the same here with Y, it just gets numbers. Okay? And here's what you guys were asking about earlier, about the test train split. This will split the data randomly. We'll randomize the data. The default is 30% of the test set. Remember I said you can change this to something else. And by using this random state equals 1, that was a question that was asked. It's a C. So that each time I run this, it will give me the same random split of the data. Otherwise, I might improve next time because it was a different shuffle. Okay, so by setting that random state means I'll get the same shuffle. Or if you're using it with someone else who's in another office, you can say set your random state to 1 so we work on the same shuffle of the data.
So the 1 is the C?
It's the C, yeah. Okay, then just real quick, just so you guys can see, did I run that? I haven't run that yet. Let me see. Okay, then here, so you can see the test train split. 70% of the data is here, and 30% of the data is here. I just printed out the shapes of them. Okay, then real quick, this is logistic regression. Fit is what trains the data. When I say fit for anything in scikit-learn, fit says training. You take this training data and train it, learn a model. And then predict says, give me predictions. Don't give me a score, just give me what you predict it would be. I don't use predict that much. I like to use score because I don't care what the prediction is. See, these are the predictions. I can't really tell if those were right or not. But those are the predictions it would give me. I could compare them to my target and see how I did. But score does that for me. So if I say score, it will just compare those item-wise and then tell me how well I did. So logistic regression for that problem got 88% accuracy. Okay, I'll just run through the rest of these and I'll. Support vector machine was perfect. Decision tree, 95% accuracy. K nearest neighbor. Don't worry right now what these algorithms are. Then this one may take a little time, hopefully not. 93% accuracy for the neural network. And if you notice here, look what it's called. MLP classifier. What does MLP stand for? MLP, what does MLP stand for? It's 444. Multi-layer perceptron, remember? Neural network. The name is also multi-layer perceptron. Okay. Anyway, that's, we're good as far as that goes. If anyone has a question, we're gonna stick around, so I know we're a little over time. I was contemplating doing some TensorFlow, but it's gonna be too hard for you guys to import. So, anyway, I'll stick around, so you guys have questions.